Hi there, Mr. Sutton here with the IM3 Honors 4-8 Part 1 homework solutions on max and min. On this problem, the cost of running a taco stand is given by this C function as a function of x. We want to know how many units x of tacos must be sold to keep costs at a minimum, and then find the minimum cost. So since this is a quadratic, we know that the minimum output of the function, the minimum value, is going to be found at the vertex. And to find the vertex, since this is in standard form, we can just use negative b over 2a. So I'll say x of the vertex equals negative b over 2a. So that's going to be negative 12 over 2 times the a value of 1. We have an invisible 1 next to the x squared there. That's positive 12 over 2, which is 6. And then, so that's the number of tacos that we need to keep costs at a minimum. And then to find the actual minimum cost, we plug 6 into the C function here. So we have 6 squared minus 12 times 6 plus 60. And I could use a calculator, but let me just do this out. I think I don't need one. So we have 36 minus 72, that's negative 36. Negative 36 plus 60 gives us 24, so that's $24. On this one, we have an object fired straight from the top of a 200-foot tower, velocity of 80 feet per second. The height of this object is given by this h function here in terms of time. We want the maximum height reached by our object and the time it happens at. Since we're trying to maximize a quadratic function, we're going to find the vertex. That'll give us the time the max happens at and the height of the max. And to find the vertex of something in standard form like this, we'll use negative b over 2a. So I'm going to say the t value, that's kind of like the x value here of the vertex, is going to be this. So that's going to be negative 80 over 2 times the a value, negative 16. And let me just plug that in the calculator. So crunching those numbers, using fancy fraction mode, alpha y equals, this comes out to 5 over 2, or I guess I could write 2.5 as a decimal. So this is saying 2.5 seconds after launching, that's when the highest height occurs. Now to find the actual highest height, we have to take this time we just found and plug it into the h function here. So basically finding the y value of the vertex, the output value. So we have all this stuff with 2.5 plugged in for t, and I'm also going to do that on the calculator. So plugging all that in, pressing enter, I end up with, hey, exactly 300. So that's going to be 300 feet for our max height. For this problem, height of a ball after being thrown upwards is modeled by this function here, where h is in feet and x is in seconds. We want to know when the ball reaches its max height and what the height is. Since I'm trying to maximize a parabola, I'm going to have to look for the vertex on this one. And to find the vertex, since this is almost standard form, I can use negative b over 2a. Let me start by writing this in exact standard form, though. So negative 16x squared plus 40x, just to put that in decreasing order of exponents. And now using negative b over 2a to find the x value of the vertex, let's see what I end up plugging in for those. So this is going to be negative b value of 40 over 2 times the a value of negative 16. And let me plug that in the calculator. So using fancy fraction to set that up, that comes out to 5/4, which if you wanted to, you could turn that into a decimal to get 1.25, and that's going to be the time in seconds that the max happens at. Now to find the actual max, which is going to be the y value of the vertex, we plug this back into one of these h functions. I'm going to go with this function here that I already created. So negative 16 times 1.25 squared plus 40 times 1.25. And I'm definitely going to do that on the calculator. So plugging that in up here is going to give me 25 exactly. Well, that's nice. So that's going to be 25 feet. That's the highest that ball will ever go. For this problem, the formula for height, which we'll call S in this one, reached by a rocket, is going to be this formula right here. We just want to find the time the rocket reaches its max height and what that height is. So since I'm trying to maximize a quadratic, that means that I need to find the vertex. And to find the vertex of something in standard form like this, I can use negative b over 2a. So I'll say that the t value of the vertex, the input value of the vertex, is negative b over 2a. So that's going to be negative 96 over 2 times the a value, negative 16. And I'll just plug that in the calculator. So doing alpha y equals and using my fancy fraction, that comes out to 3. Now what are the units on this? Well, this is a time that I just found, the best time. So this is going to be in units of seconds on this problem, so 3 seconds. Now to find the actual height at 3 seconds, I just have to plug 3 back into the function here. I'm basically finding the y value of my vertex, the output value. So I've got negative 16 times 3 squared plus 96 times 3, which I will again go to the calculator for. Plugging that into the calculator gives me back 144, and based on this problem, that is in units of feet, so 144 feet. On this problem, a new company finds their profit is related to the number of items sold by this P function here. We want to know how many items must be sold to produce the maximum profit. So I'm not sure why you wouldn't just sell as many as you could. I don't know, maybe the government charges you more money if you sell too many. I don't know. Anyway, let's use this function and find the maximum profit of this function. So since this is a quadratic, we know the max value happens at the vertex. And since this is almost in standard form, let me put it in standard form so I can use my vertex formula to get the vertex values. So we'll write this as negative x squared plus 800x plus 200, basically reversing the order of everything to put it in decreasing order of exponents. So now our vertex, our xv, is going to be negative b over 2a. So that's going to be negative 800 over 2 times the negative 1 here next to the x squared. That's negative 800 over negative 2, which is positive 400. So 400 is going to be the number of items sold that will maximize our profit. To figure out the actual profit, we just plug this back in for x in the P formula. So the vertex value for P then, with 400 plugged in everywhere, I'm just going to use the calculator for this one. So here we go, plugging all that stuff in, giving me $160,200. For this problem, we have this function giving us the height of a rocket t seconds after being launched. And this is, let's see here, this is in meters. So if you're used to these problems and there being a negative 16 here, that's because those other problems, it was being done in terms of feet. But this is actually the constant, the gravitational constant you use with meters, just random fact. So basically, we want to find the max height of this thing. So we're trying to maximize a parabola, which means we need to find the vertex. This is standard form, so to get the input value, the t value of the vertex in this problem, I can just use negative b over 2a. So that's going to be negative 68.6 over 2 times the a value of negative 4.9. And I will definitely be using the calculator for this. So I used alpha y equals to get my fancy fraction mode here. Pressing enter on all that, I end up with exactly 7. Hey, that works. So that's going to be 7 seconds with the time units here. Now to find the max height, I just have to plug 7 back into the h function. That gives me the output of the vertex, the y value of the vertex basically. So we have negative 4.9 times 7 squared plus 68.6 times 7. And now if I plug all those 7s in on my calculator, that's going to come out to exactly 240.1, and that's units of meters.